Yes, click on the subscribe button to subscribe. Today we are going to be looking at electric cells in physics. Electric cells in physics. Now we look at the number one question. The fuse in an electric device is always connected to the A. Earth side of an electric supply, B. Live side of an electric supply, C. Terminal side of an electric supply, D. Neutral side of an electric supply. The fuse, where is it connected? It's connected at B. Live side of an electric supply. The fuse is an electric device. It is always connected to the live side of the electric supply. Force current amplification. For current amplification, for voltage stabilization, for power amplification as a switch. Which of the above are the uses of a transistor? What can we use transistor for? Is it for current amplification, for voltage stabilization, for power amplification, or as a switch? A. I, and IV. B. I, and IV. C. I, and I only. D. I, and IV only. The answer is B. I, and IV. Meaning that a transistor can be used to do any of the following: current amplification, voltage stabilization, power amplification, and as a switch. Those are all functions of transistors. The most suitable cell used for short interval switches in electric bells is A. So we are looking at the cell that is used for short interval switches. A. Lead acid accumulator. B. Daniell cell. C. Nickel ion accumulator. D. Leclerc cell. The answer is nickel ion accumulator is most suitable for short interval switches. Is it nickel ion? I'll have to look at this later. In Daniell cell, the depolarizer, positive and negative electrodes are respectively. So in Daniell cell, what are the depolarizer, positive and negative electrode? A. Sulfuric acid, lead oxide and lead. B. Copper sulfate, copper and zinc. C. Manganese dioxide, carbon and zinc. D. Potassium hydroxide, nickel and iron. The answer is copper sulfate, copper and zinc. Copper sulfate is the depolarizer. Positive is copper and zinc is negative. Daniell cell is the type of cell invented in 1836 by John Frederick Daniell, a British chemist. It consists of copper pots filled with copper sulfate solution, in which was immersed an unglazed earthenware container filled with sulfuric acid and zinc electrode. A cell can supply currents of 0.4 amperes and 0.2 amperes through a 4.0 and 10.0 resistors respectively. The internal resistance of the cell is A. 1.5 ohms, B. 2.5 ohms, C. 2.0 ohms, D. 1.0 ohms. The formula for internal resistance is E equal to I bracket big R plus small r. So we have E equal to 0.4 bracket 4 plus R to give us 2 ohms as the answer C. A transistor functions mainly as A. Rectifier and an amplifier. B. Charge storer and an amplifier. C. Switch and a amplifier. D. Charge storer and as a switch. A transistor, what is the major function? It functions as a switch and an amplifier. Transistor regulates current and voltage flow and acts as a switch or a gate for electric signals. A transistor consists of 3 layers of a semiconductor material, each capable of carrying a current. A cell of internal resistance 1 ohm supplies current to an external resistance of 3 ohms. The efficiency of the cell is A. 75%, B. 33%, C. 50%, D. 25%. The answer is 75%. To solve this, efficiency is equal to work output over work input times 100. Work output is 3, work input is 1. Work output is 3, work input is 3 plus 1, which is 4. So efficiency is equal to 3 over 4 times 100%, giving us 75%. The correct position for a fuse in the diagram above is, where do we put the fuse? Is it at the live, the neutral, or earth for the device? You already know that it should be put. So A is P, which is live. B is between P and Q, which is between live and neutral. C is Q, which is neutral. D is S, which is earth. The answer is P. It will be between P and Q. So P is the live. We know that fuse is always put at the live. So in the next class, we look at current electricity. Please click the subscribe button to subscribe and share this video if you liked it. Thank you.